Hey guys, thanks for tuning in. So I'm making a video today to share with you the progress on the development of the wireless headset. It's a casual video. I just thought that there was some interesting details for anybody who is involved in or interested in engineering and product development. We've been through recently through a few steps in terms of mechanical designs that I want to get into and share with you. And I think it's just like an interesting discussion. So it's not there's no like a profound objective with this video besides simply sharing what we've been doing on our side. Let me just get you a little bit. So keep in mind projects like that. If you're interested in product development, always keep in mind that it's a very, very long process. It takes a lot of time, and it's a series of small steps that builds up over time that leads to the destination. So always keep that in mind because sometimes you see a product coming out, and but keep in mind there's a lot of work behind it. I'm tracing back just the history a little bit here because I don't know if everybody is up to date. I mean, I haven't shared, there's many information here I've never shared, so just to bring everybody up to speed. I thought interesting, I took out some early pictures of the system. So this is, on the left here is the prototype. This picture was taken in, I think it's August 2021, so that gives you an idea about 4 years ago now. And this is the prototype. I call it the prototype because there was one. This is the first, as far as I remember, this is the first data collection. I went out with the headset. I went in the streets in a few places, and it was the very first data collection with the system. You see the cable is all messed up and everything. This is the first headset. That's in November 2021. This is our first paid mandate that we had with Palais des Congrès here in Montreal that were very nice with us. I always call them ground zero. This is the ones that give us like our first chance with the system. It was so we were collecting data in a trade show. This is our set. So this is the V1. There was I think five units in the field at this time. Five or I'm a little bit maybe less, but there was definitely a few units on the floor on that day. This is the best picture I have of the full kit. The headset is actually V3, so you see I'm going V0, V1, V2. I mean I don't remember what V2 was, but now we have V3 here. V3 we did a few experiments with that. We had a good sets of experiments done with this version. So you have the headset, you have the wristband here, a shimmer wristband. Here it is what we call the amulet. This is where signal digitalization takes place. So where EEG and EMG, I'll explain that later, but are transformed into digital signals. And here we have like the portable computer, which is a Raspberry Pi as well as a battery in there, such that you can walk around with the system. And now this cable here. Now when I say we're developing the wireless system, well, obviously this one is wired, and this is what we want to do away with. So it shows you like exactly what's the component that this presentation will be about today. This is the V5. This is the currently active version. So that's the one I use when I do mandate right now. I have like 6 units. One that is owned by a client. And this is a great version. I mean, this one compared to this one was probably this one was heavy. Okay, I remember you see the electrodes build here. It was all big snaps, and it was quite heavy. And we had breakage with this one here. These branches, we ended up like breaking all of them. I mean, I think they all had repairs. And compared to this version, this one was much more bulkier, and this one is, we went back to a slicker design. We were able to go back to a slicker design. And this one also, this one takes about 2 hours to assemble from the components, the parts. This one took 8 hours. So this one was very, very tedious to assemble and manufacture. And this one, we make a step forward. There's still progress in that direction, possible progress in that direction. I'll discuss this later, but this one takes about 2 hours, I think, to manufacture. So and there's many. I mean, when you look at it, I mean, it's not obvious, but there's many small improvements. You see, I mean, you see, this is the kind of things you learn in the field. You see these we call them arceaux in French. I don't know how we would call them in English, but and you see it's zinc plated because we had actual rust building up on these elements here. So we have them plated with zinc or nickel, and probably nickel. I don't know, not zinc. And but it also gives a slick look and feel. But you see, there's many small iterations. So that's the fun of building a product iteratively, is that each version try to address a few issues. Sometimes you have some regression, step backs, and move forward. So anyway, so this is the current version. I've been using it for a year now. I'm very happy. There's a few things that we're addressing, but overall, it's a great platform to that we are at now. What is this system for? This is something I realize that some people connect here. They get here by who knows how they got here, but they don't understand exactly what this system is about and what it does. So in summary, I make it quick, but in summary, what it does, it's a multimodal biosignal data acquisition system. And we have 4 main signals that are biosignals that are captures. We have EEG, so that's brain waves that we use to measure some cognitive states. We have facial EMG. EMG stands for electromyography, and basically it's muscle activity. So we capture muscle activity from the face, and this is through this biosignal that we get emotional expressions. We have PPG, which is the name is photoplasmography. It's a light that is used to sense heart dynamics. Heart dynamics, there's heart rate and there's heart rate variability. The heart rate gives you the metabolism, and heart rate variability gives you a sense of the stress or well-being of the person. And then we have skin conductance, electrodermal activity, which is physiological arousal, how much your body is hyped up. And this is what is being sensed with this system. And also, not shown here, but we also have a POV camera that captures what's in front of the person and ambient sound as well. So through all of this, what we can do is we can do many things, but amongst other things, what we can do is measure experiences. The emotional and cognitive perspective experience of that people go. I specialize in 2 main fields. There's the whole market research, customer experience evaluation. So this is like what I call like the more serious aspects of what we do. I would include scientific inquiry in that. And then there's also the fun aspect where we work with in entertainment. We do adaptive entertainment. So that's kind of like the applications. Here it's the experience we're describing here, the experience of a immersive forest. It's called Ennois Lumina. I put the link in the description if anybody's interested. It's in Quebec City, and it's a forest that you walk through, and there's audiovisual elements that it's a cool activity. People really liked it. It feels like magical when you go there. There's lots of it's really nice. It's a very well made entertainment activity. This is what I call experiential maps. So we project in space the various state of minds. This is a very complex algorithm to get there, by the way, but it shows you like how people felt over space. And then you have like, this is the same experiment. This is the chronological map where you see it in time. So the 2 dimensions helps you highlight some elements. So when you look at both together, it helps you like better understand what people were living. One of the interesting results that came out of this experience is here. You see like this is surprise, surprise, and here is happiness, and you see there's a transition early on the experiment. The experiment, people were very surprised in awe in front of all the audiovisual displays, but as the experience move on, they switch to being less impressed, less surprised, but instead express more joy. And another interesting result is that joy was mostly expressed when people were traveling between the different immersive zones. So anyway, I'm not getting lost here, but that's the kind of experiment that we do, and that that's our main service offer. Now, I'm a proponent of the MVP approach, minimal viable product, iterative design. So the way I work is we're bootstrapping this company. So it gives you an idea. We don't have funds, VC funds. So it's really about managing your resources in a very lean fashion. And each iteration achieves some objective, both business objectives and technological objectives. And one of the core element of a iterative design is each iteration tests a few hypotheses and helps you to build your knowledge base such that the next iteration is better and better. And there's many things you can think just as much, so much about the product before it exists, and you can be so wrong about so many aspects and entirely miss some different properties that will turn out to be extremely important in the field. So this is why the MVP approach kind of says, okay, think about your iteration, make it a good, the best you can system, but don't overthink it, because when it's gonna hit reality, reality hits you hard, bro. No, when it gets into the field, you learn about a lot of things. Just the rusting problem that I discussed. We had like this Arso, and they started to rust at some point during summer. During winter, we had no issues. When summer came, because of the heat, because of ambient humidity, they started to rust, and we didn't see that coming. But good thing we had only 5 units, so it was easy to address at this point. It was a small scale problem to fix. Now, the issues with the current system. Now, besides the headset is the same system we have, the bag is actually different. We use a bigger bag now, but besides the headset that has evolved in its own direction, the issues that we have is that it's wired. Okay, so you see the cable here is a nightmare for me, by the way, because I'm an engineer, and since this wire is there, I've always seen the system as becoming wireless, but this made it possible for us to skip the development here, because this component, what's inside here, is bought. It's actually it's an OpenBCI Cyton. No, I'm not. I'm not hiding. I mean, let's be honest. But it's an OpenBCI Cyton in there, and because we didn't develop it, it made it possible for us to go on the market much faster and generate incomes much faster. But the fact that it's wired has always been like a very ugly characteristic of our system, if you ask me. It's also very expensive, and it's expensive. Now, the wristband, currently there's nothing we can do about it, but this component is quite expensive on its own. But this here, like I said, it's an OpenBCI Cyton in there, and the OpenBCI Cyton is, as of today, is 1742 Canadian dollars. Okay, that's, I think it's give or take 1,200 US dollars. It's super expensive, okay, for what it is. I mean, I'm not saying that OpenBCI is not pricing it properly. I'm saying for what it costs to manufacture, if you make it yourself, I mean, the prices are 10x. So this here, it was a shortcut, made it possible to go on the market faster, but we need, if we want to market this, it needs to be wireless, and this needs to be much less expensive to manufacture. And also tedious manufacturing, it takes, even if it takes 2-3 hours to make the kit here, if you want to make 100, let's say, no, we're talking still small volume for the type of device we're talking here, but let's say you want to make 100, that's a lot of time. 200-300 hours, that's a lot of time. So my goal is to be able to build a kit in an hour. You know, that's what I have in mind. In 1 hour, you have all your components, and you can build a kit, configure it, and ship it if that's the end goal. So these are the main issues that are currently being addressed with the current iteration, which will go to basically V6. This is one of my client. That's the only one that has a kit in hand that uses it. Is a good friend of mine, Daniel, and we have another business project that we work together. So I just wanted to shoot out to Daniel of Daniel Fournier Stratégie d'Affaires. He's an expert in customer experience, very innovative, great person. So I just wanted to give him a shoot out because he's been trusting our company for many years now. Okay, and so. Now we have issues. Issues can be turned into obviously features, and the end goal here is to have a product that is marketable, that we can bring to the market. So we want it to be wireless. We want to reduce the manufacturing cost by owning our own component. I leave aside the wristband, but no, in regard to, at least to e.g. digitalization, and we want faster manufacturing. In this project, there's many sub-components. No, you don't build this whole thing all at once. What you do is you break it down and you go step by step. For the past year now, we've been working on the electronics. The electronics is done. We have it. I have it in hand. Actually, I have one unit here on my desk. I mean, always within reach. I'm still working on the firmware, but the device itself is finished. So I have it right here. I'll explain it a little bit later what it is. And now we started for the past 2 weeks. I've been working with the mechanical engineers to move forward with the mechanics, and this is where I'll be focusing the discussion today. So this is the nucleus alchemiac. I call it the nucleus alchemiac. I can't remember where this name came from, but I thought it was a cool name, so I just stick with it. Yeah, I wouldn't be able to tell you how I came up with this name. But the nucleus alchemiac is the electronics that it has wireless connectivity. I use Bluetooth Low Energy, BLE. You have user-defined. You have 2 buttons here that can be pushed and send signals over BLE. You have status LEDs. You have GPIOs, LEDs, 8-channel biosignals. You have 9 degrees of freedom, so accelerometers, gyroscope, and compass. And there's a few extras, extra ADCs and a digital converter, so a few extra ADCs as well as I said, the GPIOs for future extensions. So this board is meant to be that you can work with it and expand its functionalities if you want to use it for a different project. So this is the nucleus alchemiac. I show it here. You see the difference in size. This is the design that resides in the amulet for the headset. That's an OpenBCI, and you see the size here. This is why this device here cannot be brought into the headset itself, because it's way too big to be worn on the head in a slim form factor. But here, this is our device, and this is much smaller, and we will be, as I will explain, we are going to be able to wear it on the head. The nucleus alchemiac has 2 versions, 2 breakout boards that comes out. So you have this one here. I call it, this is the hacker version with pin header, so it's easier if you have like if you already have like some cables, EEG cables, or we'll sell a few if you need them, so that it's very easy to just connect them and do like adapt it to basically any kind of electrode cables. And then we have this one. This is meant for products. So what you have here is special connectors for shielded cables. So this is the one we're using for our product, so it makes it possible to build a whole system with shielded cables. And why we use these connectors here is for faster manufacturing. So because we have these connectors, there's no, first, it's a very good connector to maintain shielding integrity, and you don't have any soldering to do. The idea is that you don't need a solder to assemble the whole unit, because just soldering adds quite a bit of complexity when you build. I said no soldering. Look, there's probably like 1 or 2 wires that needs to be soldered, but at least not all of these together. So the alchemiac comes with 2 different breakout boards. Now, this has been developed over the past year. It works. Still a little bit of development on the firmware, but overall we have a good system here. Now, the goal, this is where I wanted to bring the presentation. So what we're working on right now is how do we bring this unit here and the headset here and get rid of the cable. And this is what we're currently working on. The engineering approach, this is something I tell. Okay, by the way, I'm a teacher. Okay, that's kind of like my sideline is I'm teaching, and this is what I tell students. I say this is nobody will tell you through the whole engineering degree, but this is the engineering approach. This is what the methodology that you develop during your undergrad studies. So what you do is, first, when you're faced with an engineering problem, the first thing that you need to do is to understand the problem. This is a step that some people will tend to skip, but you need to really get a fine understanding of the situation that you're trying to impact on. Know what is the problem, what is the context in which this problem is happening. Then you need to document solutions. Okay, look, you need to research, look at what's been done elsewhere. In the best case scenario, you never have to invent anything new. You just build up from existing or partially existing solutions. and then you implement and follow up. This is the phase where you do the development, and then at the end of it, you debrief. And this engineering approach is actually very similar when you think about it to the scientist approach. So when you want to answer a knowledge gap in science, and it's even the same approach for medical doctor when they meet with the patient and they want to understand what are the symptoms, what is potential disease, what is the treatments that can take place, follow up, and eventually, hopefully, the curing of the disease, or at least the person feeling better. So this four-step approach, if you want to organize your ideas, is always a good thing to do, and never neglect understanding the problem. This is something I see with junior often. They tend to move past the problem too quickly. So when it comes to back to the problem is to integrate the electronics here with the device here. Obviously, the shape here of the electronics was developed with the what in hindsight of what I'm about to tell you. So the shape of the electronics was developed after I did the research I'm about to show you. And so I look over on the web. So in terms of like, there's two main tendencies of where to integrate the hardware for smart glasses. You can integrate it in the branch here, or you can integrate it behind the ear right there. Okay, and this is the main tendency. People tend not to integrate too much on the frame. Sometimes you'll find like this is usually reserved for cameras. But there's probably a reason. Probably if it's too front heavy, I'm pretty sure that the glasses will tend to fall off. And also just for the look, you want to hide stuff. You want people to when you have your customer that wears smart glasses, you want them to look like normal glasses. And if you hide the hardware on the sides and behind the head, I think it tends to show less. Now the big tendency, if you look at the market, pretty much behind the ear, you will find a few products, but mostly people will integrate the electronics in the branches there. And that's an interesting aspect, because when you think about it, if everybody builds in the branch and I build in the branch, then there's going to be kind of like a collision here, because in a future iteration of the project, I want the Alchemiac to be available to be as an accessory for smart glasses. That's something for much later. But the idea here is that here, while it seems like very natural to build electronics here, I don't want to compete on this location on smart glasses. Instead, I find that this region here is free real estate. There's not a lot of people who builds there. It's a place where it's not interfering with frontal vision. It's not interfering with weight being front heavy. People who have long hair will even hide this aspect. So that's really like where I found the most potential to hide the electronic. Oh, that's funny here. Look, this is a kit, how it's been worn. It didn't hit me that it was there. And you see, so the idea here is that's where we're building. So this is where the selection that has been chosen to integrate the electronics. So this is basically how it looks like, the concept. So the electronics needs to be here, and this is the current, like an abstraction of the current earpiece. One factor that needs to be understood is that this is adjustable, so this can move, and you see the cables here needs to slide within this hole here. This can move as well, so you see, so all of this is adjustable in this direction, and there's a few other adjustment points, but this is an important aspect, because we need to, when you adjust it, what happens is the length of the cable here change, or at least the loose that is built or retracted needs to go somewhere. You need to plan for that. And this is the design that, or at least the design, the concept that I sent to, the first concept that I sent to mechanical guys. I said, look, build the electronics, it needs to fit in somewhere in there. And this is the loose of where I want the cable to go. My first idea was to have two anchor points. We already have one here and another one here, such that if you retract or extend, here it's going to form a loop. Now we remove this anchor here to leave it like go up if it wants to. But this is the first design, and from this, there's two aspects to any product. There's the functional aspect, how it works, and all the constraints, physical constraints of how things needs to be if you want them to work. and to exist. And then there's a look and feel. And I find that at the early stage, you already need to start to think a little bit about your look and feel. And it's a fun stage to just imagine how things will look when they will exist. Now it's always a compromise between the two, because something that is very functional doesn't consider at all the look and feel, but it doesn't make a nice product, doesn't make a nice design. No, so you need to kind of like work both together iteratively to see like to always maintain. Basically, what I'm saying is at each stage of this, you always need to have a rough idea of the look and feel that is achievable with the current design functional choices. And you see, this is the first set of design. Now, notice how oh, I'm just hiding. I just realized. Give me a second. I'll just move. Woo, I'm sliding here. Notice how ChatGPT, OpenAI in this case, is just amazing. So I give it this with the prompt, and it generated several designs. Those are the two best I think that came out. But you see, I mean, it even it's me. It's almost me, you know. So it built like an image of what it could potentially look like, and this is amazing because it took me 15 minutes to get there, and roll back 5 years ago, and you had to hire a designer, and even to have like this photorealistic output. I mean, it took hours and hours of work to get there, and now you can get there in 15 minutes. Now, I'm not saying it's perfect. I'm not saying there's not any place for designers anymore. You need to have like someone. You still need someone to operate this. It happens that I have a few design over the time. I acquired a few design, elements, but ChatGPT and OpenAI is great here to take a very abstract concept and just give an idea of what it is. So this is the first design I sent to mechanical team. You see here, there's buttons here. This is what it is, and the first step that came in. You see now, this is the iteration where, okay, first design, first set of constraints. I give him a full document of all the constraints. The mechanical guys here are the ones that have been working on the headset since the first version. I know them. The name is Rupico. I put a link down below. It's a very nice guys to work with. And basically what they did, the first iteration, they simply say, let's go full functional. Let's just build like a rough part of what it could be and see what comes out. And take notice that it's very hard to see what this will look like in real life only from a CAD like that, because everything looks back. Me, I'm obsessed with the idea of making it the smallest as possible. So and when you look at this, it looks pretty big. But what we did here is, you see, I have it. Oh, you see, I have a 3D printed version of this one here. So basically, this was the starting point of the venture here. The idea was to, okay, let's just put the PCB, a little casing integrated with the existing earpiece, and let's print it without any ruckus, and just to see what happens. And already we found a few constraints that needed to be added. This part here was a little bit like this is tricky when you work with a wearable, something that you don't think about it, but sometimes here there was a risk, because this is very pointy when it reached the skin. Actually, at the moment it doesn't contact the skin, but some people are very sensitive behind the ear, and this was like the first thing I said. You know what? We don't need to go like as much like curved in so much. Let's relax a little bit the constraints here and leave it straight, so that this pointy thing doesn't come up. And here also, I think I can't remember what was the comment I left here, but probably that it was either pointy or you needed maybe. I think it's just because it was going a bit far from the system. Anyway, I think my comment was simply we need to round this out. And then you see now a new iteration of design. Again, I probably worked here, give or take 20 minutes of like new prompts, new design, new approach, new instructions. This is the straight going directly from the CAD to a black concept. And here I integrated the buttons with a little window here. There's some LEDs that comes here. I was working at some point with this triangle hole here, but I thought it was a good idea, but eventually I dropped it off. Here you see, this is a kind of like when it loses it, I ask at some point for something brainy, just like to carry the meaning of and the storytelling that we're measuring the brain. So it just went off script here with this this guy here. But anyway, that's kind of like that's design. No, that's how it works when you work iteratively with design. Anyway, so I just thought it was a funny one. Through the end of this design session, or I should say AI assisted design session, I came up with these two concepts. Personally, this is my preferred one because you kind of see a little bit the electronic. You see that something's going on here. This one is the one where you kind of hide it. No, you try to hide it. And it's interesting. I put it. So what I did here is I put it on on Discord, a few communities I'm a member of, and asked, a few people that I know. I say, hey, which one do you prefer? And this one was overwhelmingly preferred. It came out, I think, 75% of people preferred this one. A few people like this one as well. Now, this is always when you build stuff like that and you ask around, it's weird because sometimes when you ask around and people don't give the same answer that you had for yourself, there's always this mix of like, okay, do I go with my guts and just decide for myself what I think is best, or do I go with the group? And here I decided to retain the common suggestion, to go with the smoother interaction. It's still, look, we still don't know if it's going to be possible to make it like that because this is a little bit bulky when it comes to it, but we'll try to aim for something that is more attuned to this design here. But I like, by the way, I know it's always a challenge of listening and combining information coming from others, but I like to expose the concepts. I like to discuss the concept with others because I think it just like makes the thing a community project instead of just being me alone working on this. This is a first concept that the mech engineer gave me. So you see, so the only thing I didn't like, the first thing I didn't like here was the cable. The routing of the cable was pretty good, but I found that I went too low. And here we don't see it pretty well, but there was a big angle here. Even though this is a functional angle to the project, I didn't like how this was coming out. So so this is my edits here in yellow, red, and blue. So I kind of developed a little bit of a concept where the whole thing fits more with the design, and I tried to suggest ways by which this the offset here could be reduced. And this is the current version. This is the email I got, I think, yesterday, and it shows the progress. Now this is purely functional, and this is an interesting step because you see, we see all the functional aspect being in place, but the look and feel hasn't been integrated yet. So now, and those are two components that needs to be merged together, and the concept will be used to merge these two together. So it's going to be very interesting. I'm really looking forward to share with you what's going to be the next step here, because I think it's going to be an interesting transition going from here, where it's purely functional, it works. That's exactly what we have in mind in terms of like the build, the buttons, and everything that you see that where the cable fits, and the next iteration which will factor in the design as well. Now this is the part where we have like all the wireless electronics. On the other ear, this is where we find the battery component and the charging module. So currently the mechanical engineer will develop on the other side just to make sure that both sides, one of the requirements I ask is for both sides to be symmetric, and so this together will so anyway, so once the other side is functionally built, then he's going to start to work on the integrating the concept with the actual visual design. So I'm really looking forward to it. So current status, we're working on the other ear, the battery module. We're moving towards the desired look and feel, and hopefully within the next month, look, everything is always a little bit behind schedule, but hopefully within the next month we'll be able to manufacture the first unit and see what the device looks like at that point. So we're almost there. It's always exciting. Now there's been many iterations, so it's not like a purely abstract idea to a product, but I've been working on this for many years now, and several years, and it's interesting to see that we're finally reaching a point where I expect to be marketing this product. What's coming? The Nucleus Alchemiac itself will be available most likely this summer. I just have some marketing, wrap up the firmware. So I want to build some marketing elements before launching it. I want to launch it as an open firmware. It's super easy to program using a programmer like this. So if you like If you want to build around it and add new functionalities, super easy to program. It's plug and play, and I think compared to other options on the market, I think this is the only one that will be open firmware and easy to program. So I hope that this is going to be a nice feature for people who want to build around it. Open source SDKs. My goal is really to open the way here for something that is more community oriented than other. I'd say that the most directly comparable unit, if you search for it, is going to be the Geeetech Unicorn I don't want to say nonsense. Geeetech Unicorn. Let me just Unicorn. Maybe I'm not sure if they still sell it. There was Unicorn. Maybe they're not selling it anymore. I don't see it on there. So Geeetech, they had the Unicorn that was sold as a look. I think it was called the Unicorn Naked, but I'm not sure anymore if it was. But it was more expensive, and also the SDKs were extremely. The software aspect was out of price. So I want to come up with something that is definitely more accessible for hackers. Anyway, so open source SDKs, I see this as being progressively. I'll maintain obviously release software, but I hope that the community will contribute and build more and more tools around it. Accessible pricing. I think I'm looking at the 600 US for at least a first series of units. We'll see how the price evolve over time, but that's the launching price I think is doable. And I really see the launch happening during the summer. So in the next few months, probably July, maybe August, it's going to be possible. This fall, we're looking at launching the standalone headset, the Nucleus Hermes, so the standalone headset, this fall for sure. Pricing, I'm looking at 1,200 as a launch price. One thing that I want this headset to come with is many demos. I've been using it to do many super fun things, and I don't want you to see this as, oh, here's a headset that measures biosignals and then do something. I want you to receive a headset that does things already and yet is fully hackable, such that you can even expand, know what you want to work with it. So that's the Nucleus Hermes. And the Nucleus Kit, this one, that's the full feature. That's the one with the wristband, the portable computers. Now this one, look, I don't know, the portable computers is less of an issue, but the wristband itself is quite expensive on its own, and right now I'm not taking ownership of the manufacturing this element, so I don't know like how I'm going to be able to price the full featured kit. It will also probably come with many software applications to build, like I showed, chronological maps and experiential maps. So the price is a little bit less, but I think and with the market is more for professionals and scientists, because it's definitely a device that's a little bit more complex to operate and to work with. It provides lots of data, but anyway, so that's kind of like the plan that I have. But this one, Nucleus Hermes, I think for hackers, I think it's definitely a great system, a great device to play with, and hopefully that this price point will make sense for some of you. So anyway, so that's what I had to share today. Thanks a lot for tuning in. Hope you find it as interesting as I do to see like different stage of development of a product. And look, I'll make more videos as I have interesting stuff to share. But thanks a lot for being here, and that's it. Have an amazing day.